Alright, time for another DraftPhysics.com video presentation. So a follow-up to the Franklin Who thing, so we'll try to explain why I don't think waves are a practical way to understand the elemental functions. Waves show up later, okay, and the waves are made out of particles. It's not, they're made out of some things, not nothings. It's not some medium the universe isn't water. And water only makes waves in certain ways. You have to kind of understand what water is really doing, and what it's doing on the surface is a game it's playing with gravity. It's not a game that real waves do. These real waves are just pressure. It's just there's stuff or there's no stuff. So I sort of, would be helpful if everybody who's going to have a conversation about how the universe functions, that they would have some sort of conversation about the nature of atoms. Okay, and I could just make the argument, well, yeah, the atom the nucleus is a positive, so I should have done that in red and such. The electrons are on the outside, and they're in, I could just argue physical arrangement, so there ends up being distances. And those are the energy levels of the electrons, would be those distances. They are from each other. And so, some sort of model. Anyway, so I would argue the electrons aren't spinning around and doing any of that crap. It's just this geometric positions they're in, and it's all because of kind of magnetic rules rather than gravitational rules. So anyway, the idea is that somehow electrons and protons communicate with each other, all right, and they communicate in hostility or attraction. So they're either attracting or repelling. So Franklin's suggesting, okay, that you can make that out of some sort of something that happens between them, that they're sending a signal, and that the signal is based on some wave mechanics that causes attraction and repulsion. What I would sort of argue is, you really can't do that. So let's just say I did make the object go from being one size to a bigger size. Alright, now the downside of that is, so that's how I'm creating the wave. So the wave is going to be marked by the fact that it's going to be in this smaller condition, and then it's going to be in this bigger condition. Alright, so the bigger condition pushes out, and then has to go back, and then has to push out again, then has to go back. So for every push, you have a pull built in. Alright, so that isn't going to work in terms of creating a push, because you can sort of understand that, okay, let's say I had another electron and they were exactly in the right phase, so the pushes met the pushes and the push met the push. Well, the problem is the poles are going to meet the poles, and so it's going to just go back and forth, and so you're not going to be able to push each other away from each other, because one part of the wave is going to push into another piece, and then the other part's going to pull. So you can sort of understand that in an ocean wave, that when the two waves hit each other, in phase, alright, so this one's going this way and this one's going this way, it makes a double wave, alright, and you can sort of understand that what's the double wave? It's going into gravity, so it's just taking the energy here, a 1 and a 1, and it's making a 2, and the whole point of the wave is that the 2 is basically going to push back down again, and that's going to cause the pressure going forward to create the next wave. And so when it makes the 2, what you're sort of arguing is what happens is that it's not like you have a double wave. It's what you really end up with is when the 2 goes down, it pushes pressure in both directions. And so you're sending a pressure back in both directions. But the problem is, again, is if you have the negative, then the same thing is happening in reverse, and you're creating two arrows that are going to point in. Okay, so you're going to end up pulling. So you're just going to push and pull, push and pull, push and pull. So you do have to say that, okay, I'm making waves that don't have a negative element. That is, I'm not oscillating something. So something can't be oscillating because it's doing the back thing. It can't go forward and then come back. It can only be doing something forward. and then it doesn't go back, and then it does forward, and then it doesn't go back, and it goes forward. So somehow it's creating a wave that is always pushing out but never pulls back in. And I don't know how to draw that. I don't know how to mathematically or mechanically create that. So I'm arguing, that a simpler model is just to say the universe has all the energy in it. Okay? And that's just in the form of stuff moving in all kinds of directions. And stuff moving in all kinds of directions ends up being for every individual that a certain portion of the universe is heading right for you, and it's coming at you and it hits you. And that energy is just being reflected back to the universe. And depending on where this thing is moving, it's going to push back. It's going to send force back where it came from. So I move this forward, it sends more stuff to you. I move it away, you get less stuff. Okay, so that's kind of that simple. And that's because of the dynamics of the electron and proton. Like I said, I can create a system where, the electron only exerts a force that the other thing can't see, and the proton does the same thing. It exerts a force that electrons can't see. But anyway, that is inert to each other. So look, my problem is how do you create these waves? I mean, where's the energy come from? So that's the first statement you got to make. Where's the energy coming from? Is the energy coming from the outside, and then somehow your electron somehow turns energy coming in from all kinds of directions at all kinds of frequencies, and your electron somehow turns it into one consistent pulse of energy that it only releases. And again, it has to be something that doesn't have a negative component, so it's just one pulse. So the electron takes in a bunch of stimulus from the environment, so energy hits it. Unless you're saying the electron is a jellyfish, literally. Again, the jellyfish analogy doesn't work because it has the negative part. It always has to have, if you're going to have an expansion, you have to have a contraction. And you can't have this and then say two electrons will repel each other, because they won't. I mean, for every time the two waves hit each other, the two negative components will hit each other also. So if they're in phase, both segments will be in phase, which means you'll double the pulling power. So you're doubling the pushing power, but then you're doubling the pulling power. So it's really not going to work in a medium. So he says he's got some sort of experiment that shows that water produces the same effect, and I don't think you can show a water experiment that shows attraction. So you'll just be able to show the repulsion, which is based on the fact that the energy is going in one place. It's not in the universe, it's not in the ocean, it's in one place. You put it in and it just leaks out in one direction. But you're not going to explain how that would make a proton, say for example, move towards something. This is going to have the same problem. It's going to, there's going to be a push and a pull component to your wave, and unless you get rid of the pull somehow, which means you have to have just one. You have to have extra energy. If something isn't oscillating, and you're saying you're going to create an oscillation without an oscillator, so no component's oscillating except it's somehow, like I said, it has to absorb all the energy and then just release it all at once. And again, if it had a frequency, it'd have to have a frequency, and all the electrons would have to have the same frequency, or else a harmonic of the same frequency, for any of this to work, for there to be a consistent, for you to end up with Maxwell's equation, the R squared rules. You're not going to get an R squared reaction if they all aren't on exactly the same frequency, and they're forced by some physics to never be out of phase. So the electrons would have to always jump from a position that's one phase different than the past position. So even in that, I mean, even if you imagine that is a bunch of squares, you're still stuck with the problem that when it moves from here to here, from this position here, these two distances can't possibly be a wavelength of distance difference. If this is a wavelength of difference, these two lines won't be. Well, I'm kind of out of the picture. So that's not going to work. So you sort of have to, if you're going to propose the theory, then you have to explain first where the energy comes from. I mean, is the electron reflecting what it's receiving, or is it somehow producing this whatever stimulus into the environment? And again, I don't even understand how he's saying the medium is made out of the same particles the atom is made out of. That somehow there's the medium is made out of big things as big as electrons and things like positrons. Which, again, where do I put a positron in this model of the atom? Where are the positrons? Where do they hide? Anyway, it's just, no, can't make any sense. Anyway, alright, so maybe I'll think if there's some other point I have to make, but, I don't get it. It doesn't seem as simple as my model, where the electron takes in stuff that's wet and it makes it dry, and the proton takes in stuff that's dry and it makes it wet. I think that is much simpler. Anyway, so I'll think on it a little more, and or just maybe redo it again and just try to explain the point that waves aren't elemental. So you have to have them in a medium. You have to demonstrate what's waving. It can't just be a wave without a medium. And I'm not saying he's saying there's a wave without a medium. I'm just saying his medium is so big. It's made out of such big clumps that I've already explained. I can't make a straight line if I'm pushing elephants, right? Say if I have a bunch of elephants, and I just put a whole bunch of elephants around me, and I push on one of the elephants, I'm not going to get a straight line through the elephants. The elephants aren't going to bang into each other and create a straight line, because I'm not going to be able to line the elephants up in straight lines. So where's the geometry that duplicates what we see in experiments, which is I can create a photon in almost an infinite number of directions. I mean, I can have it go in a straight line in any direction. For billions of light years, it'll go on that straight line. How can it travel through the universe on a straight line when it has to do it by bumping big giant things into each other? That's not Newtonian. Yeah, no. Alright, I'm back. So, okay, just try again. Alright, so the idea is you have an electron and an electron. And so physics would say, a question to ask is, when these two repel each other, what does this force actually have to get to this object, or do they excrete something, out here, a force out here, and this bounces off somehow? The force reflects at this point. Like you send a little bit out here and a little bit out here, and they reflect here. Well, I guess it'd be the same time, because it's got to make both trips. So going going the way back would be twice the distance. So, yeah, we would notice that if there was a speed change. So it does, to me, it seems the evidence does kind of indicate that whatever this wave is, it has to actually reach the object before you can have the reflection. Yes, if you made the sun disappear, it would take 8 minutes, right? 8 minutes one way, I think, for us to know the sun was gone, because everything would seem the same, because we're waiting for the signal change. The change in the environment will take 8 minutes to get to us. The fact that the sun's gone won't be noticed, because the absorption of the pressure it's creating, the pressure the sun's blocking, won't get to us, the sunlight, for 8 minutes. The sunlight from the rest of the universe. The sun's the shadow that's absorbing, causing the gravitational differential. Oh, this is so tedious to try and go through all this explanations. All right, so Franklin's saying there's a wave being created by the electron. Where's it coming from? So that's the first question, is where's the energy come from? And what's the nature of the wave? That is the wave a push, and that's it, or there's a pull to it? And so that's the other side to it, is that problem of the pull part. So you can't just have it oscillate, because that'll create a pull. For every push there'll be a pull, and so you will negate any energy that you could use to push them away. Alright, so this phase argument, again, it's just kind of hard to draw, but I'll attempt to get to it. So this idea that somehow it creates a pressure, and a pressure, and a pressure, and then this one's creating a pressure, and a pressure, and a pressure. And somehow they only move in a way that means that these lines always line up. So when the electron moves, it has to jump from this location to, say, this location. So it's always this wavelength of distance. But again, like I said, we know that electrons interact with each other from different positions. So I could have two electrons. So I could have another electron over here. And there's no way I could create a geometry where these distances would always be a wavelength of distance. I mean, I can't force this triangle to always be a right triangle kind of thing, or I don't know what the right description of that is. I can't put electrons in any position and have this geometry mean that every single distance happens to be the same phase. So they wouldn't be repelling equally, or as we know electrons do. Well, as we're, like I said, I can't think of all the experiments that demonstrate that electrons are pretty consistent, but they're pretty consistent in obeying these R-squared rules, and you can do these calculations to figure out what the pressure is going to be, and it works out pretty well. But any change in their phase, any change in the fact that they're not going to be always in phase with each other, and how do you create that always in phase with each other circumstance? Because if they're not in phase with each other, then they're going to end up being very easy to push together, because then they're not going to theoretically feel the pressure, because the waves won't hit each other, they'll miss each other and pass through each other, would be the argument, I suppose. And again, you're still, what are the waves made out of? So in his theory, the waves are made out of objects just as big as the electron. A positron-electron pair, I think, is what he calls it. So it's some composite of an electron and a positron that, they're just connected in the universe. So so the geometry would be just some sort of, the whole universe would just be a checkerboard, right? Yeah. So everything would just be, electron, positron. Well, this has to be an electron here. This has to be an electron here. And then you have positron, electron, and positron. Whoops. Yeah, that's an electron. Yeah, that should have been this one should have been an electron. This one should be a positron. Yeah, so you have to, they can't line up at all. So, okay, I did it wrong. These would be here, here, and then you'd have here, here, and here. Okay, sorry about that. So, a lot to keep track of. Alright, so that's the idea. Alright, that's better. Alright, and somehow in that field, you're going to take an electron or a proton, and somehow it's going to move these things into each other in some way that this communicates with this in a straight line. And you can sort of understand, if I put the electron here and the other electron over here, that there's no straight line I could make. There's no geometry that's going to be able to convey a pushing force in any way, or for that matter a pulling force. A pulling event, where this one moves a little bit this way and therefore these move that way. I don't know exactly how he... So yeah, this is the point where you're saying, I don't think you can do a true mechanical drawing besides doing something this simple and just saying somehow they always are in phase with each other, and somehow their waves always hit each other on the peaks, and there are no crests. So there is no yin to the yang. There's just out and then out and then out. No ins. No trough meeting trough and creating a double trough, a double pull. Alright, so that's another shot at it. Maybe I'll take one more shot and see if I can get to the elemental points. Which again, I would just say the Newtonian argument is that it's just about pressure, and you have to first account for where the pressure is coming from. At least in my model, all of the energy comes from the outside. So anything that moves because stuff on the outside hits it and sticks to it, in some circumstances. But there's no energy in these objects. They don't do anything except get moved around by the force, which I would argue does fit the evidence. That's what, if something's moving, you just look into its history and see what moved it, and it's going to be a force that moved it. Alright, one more try. Alright, so back to the ping pong ball example, right? So this one's pretty easy to understand, that if you have a ball that bounces between two ping pong two paddles, and the ball always moves at the same speed, that would be the speed of light, alright, that it's going to create a certain amount of pressure on the two sides based on its speed. So its speed is consistent. It hits the sides a certain number of times, and each time it hits the side, let's just say it does impart a little bit of a push, okay, as it reflects. That's pressure. And then the closer you make the two sides, you can understand the same ball will bounce. If I make it, let's just say it was twice, not this is a little bit more than twice, you could just say, okay, I know it's going to hit. So if it hit 5 times a second here, it's going to hit 10 times a second here. 10 times a second is going to be more pressure. Obviously, it's going to be more pressure pushing it apart. So it'll do the inverse square law kind of thing. It'll create more pressure as you bring the two things closer together, blah, 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 blah. So it's sort of an understandable mechanism that the energy, is just dependent on this pressure from the outside. And the fact is that if I make these two things far enough apart, I create a low pressure in here. And if I bring them closer, then I have high pressure here and low pressure, relatively speaking, on the outside, and the things will move out because the pressure won't be even. So again, you're just saying, okay, so you're saying electrons are communicating with each other through some sort of medium. Well, what is the medium? How's the medium controlling that interaction? And again, how do you convert the stuff coming from any direction or any point in space coming at different time? This one hits at this time, this one hits at this time, this one hits at this time, this wave or whatever you want to call it, and then somehow the electron converts all of that into one wave it produces, at one constant frequency, at one constant rate. So again, just back to this timing issue, how can I time things to be in phase and out of phase? Because as I change the distance, I'll change being in phase and being out of phase. They won't stay phase matched, if that's the word to use. How do you force them to stay phased matched and always be in phase to whatever the mechanism is of these two? You're saying, look, if I throw a rock at somebody else, I don't know anything about it, right? Whether it hits them or it doesn't hit them, I won't feel anything, okay? There's no way I can know that these two waves, if I'm an electron, how do I know this wave hit this wave? Would be the argument, right? So the only way I could know it, I guess, is if it got to my surface or something. But how could I know what the waves are doing, and why would the waves compel me to move? So you really do have to make the argument that the wave has to somehow get to the object. So cancellation doesn't make much sense. I mean, just they have to be capable of just going and actually hitting something with a positive pressure, a positive momentum. And so why don't you just make it that simple? Why don't you just forget about the interference part and just say electrons are producing a wave at a different frequency, a different phase. So, the electrons are this phase, and the proton would be in here, at this phase. And then you could still just argue it still has to hit the object. So you could just have the waves travel through each other, and you'd be stuck with the same argument, because really it's about the placement. You can't fix the placement problem, the distance problem. So I guess I don't see how you can create electrons that are repelling each other and protons attracting, with an oscillating wave. Yeah, no, I don't get it. Unless the wave doesn't have any negative component, but then you still have the same problem where the wave is made out of the same stuff. Then why wouldn't it push the proton just as easy as it pushed the electron? I mean, why would phase matter to where it's hitting the object? Why would the object care whether it's in phase or out of phase? So then you're back to your dependency on the medium doing the work. And even in water, the pressure you create, the back pressure you create would not be anything. I mean, the pressure is always going out from the object that you drop. So if you drop 2 pebbles in, the waves aren't going to push those centers away from each other. So if I drop a rock over here and I drop a rock over here, the waves can bang into each other all they like, but it's not going to move this location where the water's still oscillating up and down. It's not going to move that oscillation and move this oscillation away from each other. So you sort of have to explain how that can happen, because that's what electrons do. They move away from each other. Alright, I'll leave it at that for now. But yeah, not enough information, frankly. Again, the electron-positron pairs doesn't make any sense, because then photons have to be made out of, have to be gigantic, monstrous things. And if they're gigantic, monstrous things, then how can they hit little, tiny, discrete locations? But anyway, call it enough of a video and such. But yeah, I think my simpler explanation works better. That's, but there's really no point in arguing that. What we ought to just argue is, can we draw the same diagram of even how the electrons and protons are arranged in the atom? Do we have anything we can agree on? I mean, that's the tricky part, right? Because maybe there's absolutely nothing we agree on.